looking at question number 35 out of chapter 7. The question has a connection to drinking milk in the cereal bowl. It says p hat's a proportion of people in the sample of 1,012 who drink their milk. The spokesman claims it's 70%, and we're going to believe it to be true. What is the mean of the sampling distribution of p hat and why? Well, since we have a random sample, the mean of all the p hats is the truth. This is an unbiased estimator because we have a random sample. Now part B says find the standard deviation of the sampling distribution of p hat. Well, if the 10% rule is met, then the standard deviation of the p hat is the square root of p times 1 minus p over n. P times 1 minus p over n, and that's 0.0144. Now that's if the 10% condition is met. So what is the 10% condition? Well, in this case, my sample size was 1,012. The question is that more than 10% of the population? Well, in this problem, we're asking about U.S. adults. So since the number of U.S. adults is way bigger than 1,012, 1,012 times 10. Back up just a little bit. 1,012 times 10. Since it's way bigger than 10 times the size of my sample, the 10% rule is met. And the reason this is important is because if I sample more than 10% of the population, then the people that I'm sampling have a lack of independence. The probabilities are changing with people that I've already drawn out of the population. But if the population is way bigger than the sample, that effect is negligible, and we'll consider the people in the sample to be independent from one another. Now, part C says, is the graph normal? Well, this is the large counts condition. The large counts condition says that NP needs to be bigger than 10, and N times 1 minus P needs to be bigger than 10. Or in other words, 1,012 times 0.7 needs to be more than 10, and 1,012 times 0.3 needs to be more than 10. Well, in this case, 1,012 times 0.7, that's 708.4. Yeah, that's bigger than 10. And this is going to be 303.6. Yeah, of course, that's bigger than 10. Sometimes we refer to this as 10 successes and 10 failures. Since this rule is met, the sample size is big, we have large counts, and therefore the sampling distribution is approximately normal, and therefore the sampling distribution is approximately normal. Now from these three parts, I end up with a normal curve with a mean of 0.7 and a standard deviation of 0.0144. 0.0144. And now I can use this to get part D. So part D said, find the probability of obtaining a sample where 67% or fewer, 67% or fewer. So what is that black region right there? So what's the probability that my sample would be less than 67%? I'm going to standardize it according to the mean that I got in part A and the standard deviation that I got in part B. and my z-score there is negative 2.08. And then since I know it's a normal distribution, I can use my normal chart and find that this area right here is 0.0188. Now that means it's not very likely that I would get a sample this small. There's only a 2% chance, less than a 2% chance really, that I would get a sample of 1,012 people where 67% or fewer drink their milk. So either I got really lucky to get a sample like that, since it only happens less than 2% of the time, or the original claim of the milk industry is not accurate. It's overstating the truth.